I would strongly suggest with this video that you actually print out the notes. The reason being, before I start going over the new topic, which is what we call the discriminant, I'm going to go over the solving process to 3 examples with the quadratic equation. The reason being is we're going to talk about how we can predict the number of solutions. It'll be easier to understand the reasoning behind our predictions if we look at some different examples first of all. And these are all 3 solved out in your notes for you. So notice with this first one, the first thing I did was I needed to get it in standard form. So I subtracted the 2 from each side. And then because this wasn't something I wanted to factor, and because there was both x squared and x, I knew I needed to use the quadratic equation, giving me x equals negative b plus or minus b squared minus 4 times a times c all over 2a. Cleaning that up, my 5 and plus or minus drops down underneath the radical. Negative 5 squared gives me 25. Negative 4 times 3 is negative 12 times negative 2 is a positive 24. Again, cleaning up what's under that radical, this leaves me with 5 plus or minus the square root of 49 over 6. Now, I've said before that when do we stop? Well, if you can do the math, do it. Since I know that the square root of 49 is 7, I go ahead and do that. And then because I'm able to actually add 5 plus 7 to get 12, and 5 minus 7 to get negative 2, I do that as well. Then simply reducing 12 over 6 gives me 2. Negative 2 over 6 gives me negative 1/3. So when I'm asked the question of how many solutions will it have, notice that I come up with 2 solutions. One thing I want to point out, because this is where we're going to be heading with what we call the discriminant, I got 2 solutions when my number here under the radical was a positive number. If I talk a little bit further about my solutions, notice that both of these solutions can be classified as real numbers. Looking at the next example from your note set. I do have one more quadratic equation, again not in standard form, so I subtract that 16x. Commutative property says it doesn't matter what order I add in, so I can stick it in the middle of the 4x squared and the 16 so that I am in standard form. Again, not wanting to try and factor this, although looking close at this may be something that is factorable, but for demonstration purposes I am going to put it into the quadratic equation, even though if I were solving this on my own I probably would factor out the GCF of 4 and then try using a factor sum table. But plugging it into the quadratic equation, negative b plus or minus the square root of b squared minus 4ac all over 2a, cleaning up under my radical, negative 16 squared as we know is 256. Negative 4 times 60 is also 256. 256 minus 256 leaves me with 0. Well, I know the square root of 0 is just 0. So having this here is absolutely meaningless. So if I just drop down the 16 and the 4, 16 over 4 then reduces to 4. Notice this time I got 1 solution. And in terms of it being a real or imaginary solution, it is a real solution. There is no I attached to it anywhere. Let's see, real number. And I got 1 solution because I was not able to add plus or minus anything. The reason being because I had a 0 under my radical, which is what brings us to, now that we've gone over these 3, our new topic of the discriminant. So, talking about the discriminant, so notice that the discriminant is that tells us the number of solutions a quadratic equation has, and if they're real or complex. Complex being just another word for imaginary. When we are looking for the discriminant, we still have to be in standard form. So given a quadratic equation, ax squared plus bx plus c equals 0, b squared minus 4ac is the discriminant. This should look familiar to you. You should have seen b squared minus 4ac before. You should have seen it right here in the quadratic formula. So the discriminant is supposed to tell us the number of solutions. Well, we just looked at 3 examples. In the first example, the number under the radical was a positive number, a positive non-zero number. That gave us 2 real solutions. The second example we looked at, the number under the discriminant, was a negative number. That gave us 2 imaginary solutions. In the third example, the number under the radical or the discriminant was 0. That gave us 1 real solution. That is what we're going to use, those 3 concepts there, to determine the discriminant. So I'm going to add that into my notes. So if b squared minus 4ac is greater than 0, I get 2 real solutions. If my discriminant, b squared minus 4ac, is less than 0, I get 2 imaginary solutions. And finally, if b squared minus 4ac equals 0, I get 1 real solution. At this point, let's look at some examples actually using the discriminant. So if I look at my first example here, if I'm asked to find the number of solutions as opposed to solving it, to find the number of solutions, all I need is that piece from under the radical, is that discriminant, b squared minus 4ac. So I'm going to go ahead and take my b, which I see as negative 5. I always want to plug negatives in with parentheses so I don't mess with my order of operations. Minus 4, my a, which is 2, my c, which is negative 3. That gives me 25. Negative 4 times 2 is negative 8, times negative 3 is a positive 24, and I do get a 49. Well, keep in mind that if I were to work the whole thing out, the form of the quadratic equation would be something plus or minus the square root of 49 all over something. Well, how many solutions is that going to give me, and what kind of solutions? Well, my first solution is going to come from taking that something and adding the square root of 49 to it, and then dividing by this number here. I know it's going to be real because 49 is a positive number under a radical, and I only get imaginary numbers if I have a negative under a radical. My second solution is going to come from taking this something and subtracting the square root of 49, then dividing by this. Again, I know it's still going to be real because I have that positive number under the radical. So from my discriminant, I'm able to predict that I will have 2 real solutions. Notice the discriminant does not give me any information on what my solutions are, only how many there are and what type they are. If we look at another example, again, I have a quadratic equation here. It does not ask me to solve it. I'm only going to predict my number of solutions. So predicting my number of solutions, all I need is my discriminant, b squared minus 4ac, again pulling it from directly under that radical. My b this time is 3, so I have 3 squared minus 4. My a this time, remember, if there is nothing written in front of the x squared term, it means your a is 1. And then my c is my constant of 5, giving me 9. Minus 4 times 1 times 5 is 20. Well, 9 minus 20 gives me a negative 11. What does that mean? Well, again, if we think of it in terms of what does it mean with a quadratic equation, it means I would have some number plus or minus the square root of negative 11 all over some other number. Well, that means to me that because of this negative under the radical, I would pull an I out. This is going to be a complex or an imaginary number. How many solutions am I going to get from this complex or imaginary number? Well, I'm going to get this plus my imaginary number divided by this, and this minus my imaginary number divided by this, meaning I am going to get a total of 2 imaginary solutions. And then looking at one more together, and then I will have one that you can try. I have here example 3. Again, going ahead and predicting what my number of solutions is going to be. I see that I am not in standard form. This minus 25 needs to go over to the other side. I can get it over there by adding 25 to both sides, giving me x squared plus 10x plus 25 equals 0. Using the discriminant, giving me b squared minus 4ac. My b this time is 10. My a once again is 1. And my c is 25. 10 squared, of course, is 100. minus 4 times 1 times 25 is minus 100, which does simplify to be 0. Well, again, if I think of it, what does it mean in terms of the quadratic equation? It means I have something plus or minus the square root of 0 all over something. Well, this is absolutely meaningless. The square root of 0 is just 0. So adding nothing to something does not change it. So I could actually say this is the same thing as just something over something. Well, that's a fraction, one single fraction. So in terms of how many solutions does that give me? It gives me one real solution. Remember, the only way I can get an imaginary number is if I have a negative under here. I know that this term here is not going to be negative because that, if I'm thinking about my quadratic equation, that term is just negative b. This term here is just 2a, so those will not be negative. I don't have to worry about that. Finishing up with this last final example, this would be a good opportunity for you to push pause and try this on your own and see if you can predict the correct number of solutions and what type of solutions you'll have. Okay, hopefully you've been able to finish this problem. So the first thing I notice with it is I am not in standard form. I have said this before, it is weird for me to have a negative a term. I don't like it. So rather than move just the 8x squared over to the right, I am going to move the 2x and the minus 3 over instead, giving me 8x squared minus 2x plus 3 equals 0. Now that I'm in standard form, I can predict my number of solutions by looking at my discriminant, which is b squared minus 4ac, plugging in a minus 2 for b, a 8 for a, and a 3 for c. Negative 2 squared does give me 4. Minus 4 times 8 is negative 32. Times 3 is minus 96. And if I subtract this, I notice I do get a negative 92. Well, again, if I get a negative underneath my radical, if I'm thinking about where this discriminant came from, that would give me an imaginary number because I would have something both plus or minus this. I know that that would also give me 2 imaginary solutions.Tomorrow in class we will do some group work with this, and I am going to show you a sweet video. Hopefully YouTube will work with some ways to help you to remember this as well.